All right, ladies and gentlemen, the cumulative review section. Please do not forget that this is 20% of the test. The last page is always worth 20%. If you don't quite get some of this stuff, remember you can go to Khan Academy and you could watch some stuff on there if you need to. All right? But if you follow along, hopefully this will all make sense. So, number 38. What is the area of a rhombus with diagonals of length 4 and 5? Well, the area formula for a rhombus is diagonal 1 times diagonal 2 divided by 2. So, we simply go 4 times 5 divided by 2, and we get 10. Now remember, area would be labeled centimeters squared. Number 39, area of a circle. Okay, that one we should all know the formula to. Area equals pi r squared. Okay, leave your answer in terms of pi. So that means we're going to leave it alone. We don't want to touch it. So here we go. So the area is going to equal pi times 12 squared, because the radius is 12, and 12 squared is 144. So the answer is the area equals, put 144 first with the pi symbol behind it, leave the pi symbol alone, and now put the units on it, inches squared. So 144 pi inches squared. All right, number 40. This time we have the area of a trapezoid. Okay, the area of a trapezoid equals the height times base 1 plus base 2 divided by 2. Plugging the numbers in, so the height is 5, the base 1 is 6, base 2 is 9, divided by 2. All right, remember order of operations, don't forget PEMDAS. So following the order of operations, we would then have 5 times 15 divided by 2, which is 75 divided by 2, which is 37.5, and the units are inches squared. All right, number 41. The area sector of a circle. Oh, area sector. So that means we are going to take the degree that we are using divided by 360. Now remember, there's 360 degrees in a circle, times pi r squared. All right, here we go. So we want to know for a 45 degree, angle of 45 degree. Angle of the sector is 45 degrees. So we're going to go 45 divided by 360 times pi times 10 squared. And again, it says leave pi alone. Well, calculator, I'm going to do this. So I'm going to take 45 divided by 360, and then I'm going to multiply that times 10 squared. It looks like 12.5. All right, so when I did all of that, I ended up with 12.5 pi, and the units are meters squared. Number 42. Determine f of negative 2 when f of x equals 3x plus 7. So all we're going to do, ladies and gentlemen, is we're going to replace the x with a negative 2, and we're going to solve it. So 3 times negative 2 is negative 6 plus 7, so the answer is 1. Same thing with number 43. All right, so we're going to replace the x with 2, so the f of 2 equals the absolute value of negative 2 times 2 minus 5. All right, I'm going to simplify the inside, so I've got the absolute value of negative 4 minus 5, which equals the absolute value of negative 9. Now remember, absolute values are always positive. So that means the answer is 9. All right, number 44. Oh, some more conversion. Okay, that's not going to go away. So, what do we know? We know that, well, first of all, 45 miles per hour. So 45 miles per 1 hour. And I want to convert that to feet per minute. Okay, well, first of all, I am going to convert my miles into feet. So I'm going to put 1 mile on the bottom so that I can cross off the miles. And what do I know about 1 mile? It's 5,280 feet. Okay, then I need to get rid of the 1 hour. So I'm going to put 1 hour up here so that I can cross the word 1 hour off. And since it's minutes, how many minutes are there in 1 hour? There are 60 minutes. Multiply the top, I get 237,600. And on the bottom, I have 60. Divide those, and I get 3,960 feet per minute. Okay, number 45. Two lines intersect each other in exactly blank points. Okay, so if I've got a line here and I got a line that intersects it, it is going to intersect in exactly 1 point. Two planes intersect each other. Okay, well, that's a little bit more difficult to draw. So let's see if I can even attempt to do this. Remember a plane. I'm going to back this up, and I'm going to circle this again. There we go. So a plane, okay, is a flat surface that goes on forever. So like if I had, let's say that is a plane, and again, it's going on forever. It's a flat surface. And then I have another plane. Boy, this is really difficult. I have another plane that intersects it. Okay. So where it intersects, okay, let me redo that a little bit. So you got to imagine that it's like sideways. One is vertical, one is horizontal. So they intersect each other. Okay, well, that's going to form a line. When two planes intersect each other, that's going to form a line. Okay, my drawing, that is a bad picture. Okay, you're going to have to try to use your imagination on that. Think about two pieces of paper that go on forever that intersect each other. All right. So what do we know about two lines? Can two lines intersect? Yes. Can two lines be parallel? Yes. Okay. Can two lines be skew? Yes. So all of the above. Two angles that lie on a straight line are, okay, two lines lie on two angles. Oh wait, two angles that lie on a straight line. Okay, so two angles that lie on a straight line. Here's angle 1. And okay, so here's an angle. And here's an angle. Okay, those two angles lie on a straight line. Yep, they're supplement. And they're adjacent to each other. So it's both A and B. Remember, adjacent means next to each other. They are next to each other. Supplementary means they add up to 180 degrees. And if that's a straight line and it intersects it, it is 180 degrees. All right, that is it for the study guide for Chapter 2, ladies and gentlemen. Good luck.